All right, team. This is the video that is supposed to make up for my absence today. I apologize for not being there. Sometimes you can't control your health. So this is the second half of section 7.2. On Friday we started 7.2, and today we're going to do the second half. So let's see here. Let's move along. So remember the rules, these addition rules for sine and for cosine and for tangent. Those are going to be used quite a bit in today's lesson. So if you're watching the video, you might want to take a screenshot of these or copy them and print them just so you have access to them. Okay, so we're going to, our first example is we want to evaluate sine of theta plus sine of phi, where sine of theta equals 12 over 13, and with theta in quadrant 2, and phi or phi or pho or phum. Tangent of phi is 3/4 with phi in quadrant 3. And I apologize to all of you in Greek organizations because I'm butchering the Greek letters. So we're going to evaluate this, and I'm going to just I'm just going to draw these, put these triangles in. If sine is 12 over 13 and it's in the quadrant 2, there's 12, there's 13. We use the Pythagorean theorem to get the third side, which would be -5 in this case, because the x values in the second quadrant are negative. Here is phi, and our tangent is -3 over -4 because it's in the third quadrant, and then we use Pythagorean theorem. We get the hypotenuse is 5. Okay, so these are important. Remember, the sine is 12 over 13. What's the cosine for for theta? And I love writing with my mouse. I'll try to do this quickly. Is what? -5 over 13. And let's see, sine of phi is going to be, sine of phi is going to be negative 3 over 5, -3 over 5. When you're doing these problems, really just, it helps to just write these down. Then you have them, and if you write down sine and cosine of each angle, you have them, and then you can just substitute them into the values. No use in trying to memorize things. It's just having tools, and this is one of your tools, is to write these down before you start the problem. Okay, let's get to the next slide. So there's the ones we've written. We substitute in the values into our addition formula, and we hit calculate, and there's our answer. So once you've got all the different sines and cosines, you just substitute in. Here's one you should try. So this one is problem number 55 out of section 7.2. So it's in the task section. So you can do this problem and then go into your ebook, go into the problem set for section 7.2, find number 55 and see if you get the right answer. Okay, so pause your video and do that, and then come back. Okay, so now we're shifting gears a little bit. We're going to look at expressions of the form a sine x plus b cosine x. And we're going to write these expressions, a sine x plus b cosine x, in terms of a single trigonometric function, using the addition formula for sine. Yay! There's that addition formula for sine. And so here we're going to start with this expression right here, 1/2 sine x plus √3 over 2 cosine x. Now what we're going to do is we're going to say that the 1/2 and the √3 over 2 are related. So the 1/2 is going to be cosine of phi, or phi, or phi. Let's just stick with phi for right now. And our sine of phi is √3 over 2. And why would we do that? Because it comes from the sine of phi plus theta. Remember, it's cosine of phi, or actually in this case, sine of phi plus x. So it'd be cosine of phi sine of x plus sine of phi cosine of x. That's from the summation formula for sine. And so what angle has a cosine of 1/2 and a sine of root 3 over 2? Yep, you guessed it. It's pi thirds. So now we can rewrite this. We write the original expression as cosine phi sine of x plus sine phi cosine of x, and that gives us sine of x plus phi, or phi. Gosh dang, I'll figure it out. Just know that if I say phi, it's probably phi or phi, but it's not pho or phum. Okay, that was a bad joke. And then phi, of course, is pi thirds. That's what we're shooting for right there. Okay. So let's generalize a little bit. So notice what I've done here is I said, well, if A is the cosine and B is the sine, I come all the way down here and I make a right triangle. And you remember when in our unit circle, A was the x-coordinate was the cosine and the y-coordinate was the sine. So there it is. There's A is our x-coordinate because it's the cosine, and B is our y-coordinate because it's the sine. Then we use the Pythagorean theorem to find the hypotenuse. Then what we do is we are going to multiply both sides of this equation by root a squared plus b squared over a squared plus b squared. In other words, we're going to find an equivalent expression, and we're multiplying it by the both numerator and the denominator by the hypotenuse. And then when we do that, notice when we do that, right, we get this constant out here, but this is just cosine, and this is just sine, like I have down here. Okay? And so once we've done that, then we can just say, oh, well, that's just cosine phi sine x, sine phi cosine x, which is sine of x plus phi. And this a squared plus b squared is that's the hypotenuse, but it's also a constant that we're going to have out in front. And so here's the rule. This is the rule here. If we start out with a sine x plus b cosine x, we're going to have some constant k times sine of x plus phi, where k is the square root of a squared plus b squared, and phi satisfies these relations. The sine of phi is b over a squared plus b squared, square root of a squared plus b squared, and cosine phi is a over square root of a squared plus b squared. Okay. So this rule's another one you're going to want to have down. And again, on the test, I will make sure that you have all the rules, everything you need. And you'll just have to know how to use them. So here's an example. We're going to express 3 sine x plus 4 cosine x in the form k sine x plus phi. Okay, so first thing I need to do is I need to get my k. And if 3 is my a and 4 is my b, I just substitute them into the formula for k, and I find out that k is equal to 5. Now cosine is just a over k, and so we have 3 over 5, and sine is just 4 over 5, and we're in quadrant 1 because everything's positive. And so we do inverse sine of 4/5 to find phi, and through the magic of your calculator you get it's about 53.1 degrees. So then you substitute in your values, your 5, which was your k, and the value for phi, which is 53.1. Okay. Real quick, just a thought, since this is a video, you can stop and rewind. So go through and rewind this again and make sure that you understand what's going on. So here's one you can try. You could even rewind, watch that last slide again, and then try this one. So pause it. Okay, there's the solution. Notice I found my k, which is just the square root of a squared plus b squared, and a was negative root 3, and b was 1, and came out to be 2. My cosine of phi is going to be root negative root 3 over 2. My sine is going to be 1/2. And so we do inverse cosine of root 3 over 2 is 5 pi sixth. Notice I've got my triangle here, and just to help me, and so then our final answer is going to be 2 sine of x plus 5 pi sixth, because 2 is there, there's your k, and 5 pi sixth is your phi, and so there it is. Okay. One more, a couple more. Write the function in the form k sine 2x plus phi, and use the new form to graph the function. Okay, so let's go to it again. So we know our a is -1 and our b is root 3. So through the magic of math, we get that k is equal to 2. So there's your k is equal to 2. Then phi satisfies cosine of phi is -1/2, and the sine of phi is root 3 over 2. So our angle is 2 pi over 3. Just a quick note, if you can always just grab a picture of the unit circle and find these, and when you find these, that'll give you the angle right there. You know, it's just whatever tool you use to figure that out, and perhaps I'll put a unit circle on the exam cheat sheet as well. So here we go. There's our angle, and we've got our k, so we can rewrite it like this. Now, rewriting it like this is great, and we got the answer, but we need to factor out a 2 because we want x plus an angle. We want this to be just an x and this to just be an angle, so we factor out a 2, and so there you are, there it is, boom. And you remember 2 has to do with the period, this 2 has to do with the period, this 2 has to do with the amplitude, and this pi thirds has to do with the shift. Okay, so it's your turn. Go ahead and try it and then graph it. So pause your video right now, go. Here's the solution. I first found k. K was 2. Cosine of phi is a over k, so that's 1/2. Sine of phi is b over k, that's root 3 over 2. So our good friend pi thirds is, so phi is pi thirds. Maybe I made a mistake. Maybe that's phi is pi sixth. Anyway, when you go through this, there's your k, there is your angle. This really makes me angry. 2 secs. Anyway, when you get your angle, you put your angle in here, and then notice if this is a 2x, we want to divide it out so we can graph it. So we divided 2, and when we divided 2, it changes the denominator, and then you graph it. Whew, we're all done. Thanks for playing along.